Hi all, welcome to our GradStats 2024 lab series. For Lab 5, we're working with Chi-Square tests. And the Chi-Square is a non-parametric test that is used when our data are categorical, and we're looking to see if the data values and frequencies that we have in the data set are significantly different than what we would have expected. Now, the two types of Chi-Square test we'll be working with today are the test for independence and the goodness of fit test. And materials you'll need for the lab are the Dataset survey.sav from Palant, and the lab sheet that we used with SPSS helps guide the way as well. So let's get those items and we will get started in JASP. So opening the data set in JASP, it's the one we're used to, where they've already kind of labeled everything pretty well for us. And it's got the totals at the end, these totals, positive affect, negative affect, life sat, and they have these extra variables that are ordinal at the end as well. And our goals here are to look at the distribution of variables. Are they aligned with what we expected according to the data, or the observed data? Is it different? Are these significantly different? First, we'll start out with getting some descriptives. And the variables that we're interested in for this Chi-Square lab are sex and source of stress. I'll hold down the Command or Control key so I can select items that are not in a line. And then the last one, smoke. I'm going to throw those over so that I can get an idea of what's going on. Now, for categorical variables, the mean and standard deviation are not worth anything to us. Like if sex is coded as 1 and 2, saying that I have a mean of 1.6, okay, thanks, right? So what we want to do is look in our statistics area, and we don't need the mean. We don't need the standard deviation. We pretty much already know min and max because that's how we're coding those levels, like the levels of source and stress, and the levels of yes or no, you smoke or don't. So all this table really helps us with so far is knowing how many missing cases are present. But then we're going to also want a frequency table here. There we go, in tables at the bottom. So frequency tables, now we have that descriptive information that we're used to. How many males, what percent of the whole do they represent? And if we're looking at just the ones who reported, we would look in the valid percent column. If we were looking to also talk about how many did not tell us their gender, then we would work from the percent column. Either way, just be consistent. If you're going to use valid percent, keep doing that for the whole thing. So now we have a lot of information that we can use in describing those categorical variables to our reader. Next, we will work on the Chi-Square test. And to get that, we need frequencies. I'll go to frequencies and contingency tables. Now here, this is going to be our Chi-Square test looking at the question, is there an association between gender and smoking behavior? So I'll put Chi-Square, this is my 2x2 table of sex and smoke. Now, what a Chi-Square test for independence does is look at if there is any kind of dependency between these categorical variables. In other words, it looks at the observed frequencies, like how many people indicated male or female or smoking or non-smoking, like the actual observed values, and comparing that to the expected values if there was no association. Like if there was just a similar distribution as you would expect with however many males and females you have, then we would see a non-significant chi-square test that has no dependencies between smoking behavior and gender. Whereas if it was significant, it would indicate that someone's smoking behavior may be dependent on what gender they are. So let's take a look. We're going to put sex in the rows and smoke in the columns. And as a 2x2 table, it really doesn't matter which one we put where. But when you have something with a lot of levels to it, then you kind of want that one in the rows field because it's going to make your table easier to manage. So let's see what we have here so far. We have, out of the 184 males, 33 of them said that they smoke and 151 of them said they don't smoke. Similarly, out of the 252 females who told us their smoking behavior, 52 of them said they smoke and 200 of them said they don't smoke. So this is good starting information, but we need to know how many were expected. Well, we'll go to cells. That's where we want. And go to expected. Now we see more information. We expected almost 36 males to say they smoke, but only 33 said they did. We expected 148 males to say they don't smoke, but 151 said they did. So that's what the chi-square test is looking at, is the difference between what was expected and what was actual significantly different, which would indicate that there might be some dependencies between smoking and gender. And this gives us a lot of information that we can work with when we're trying to convey the results to our reader. Now the next thing here is the chi-square test results. And this one's tricky because a regular chi-square is not what we want to use for a 2x2 table. It's kind of a special table because it's so little, and we need to use the Yates continuity correction to get a more accurate chi-square estimate here. And to get that, we want to go up into the statistics part of the panel and get the correction. And now we got a new line, a new row on our results. So our chi-square value is going to be 337, degrees of freedom 1, and p-value 0.562. And looking at this, is this a significant test? No, it's not, because the p-value is not less than 0.05. And with a non-significant chi-square test, that means that we have a relatively even distribution across those categorical variables, signifying that there's no relationship between them. Now, what else do we need to be able to write this up? We have the chi-square estimate, we got degrees of freedom, we got the p-value, the significance value. What we're still missing here is the effect size. And the effect size we use for a 2x2 table is called phi. Whereas if we have a bigger table, it's Kramer's V. And our little checkbox here would give us both, but because we have a 2x2 table, we're paying attention to the phi coefficient, which is negative 0.034. Now that's pretty weak. Think of it like your correlation magnitude cutoffs, like 0.1, 0.3, 0.5. A 0.1 is weak, and this is 0.03. So very weak, which makes sense with a non-significant test. Now, is there any other information we want in here? Let's double check. Nope, that makes sense. Okay, so that's the information for chi-square on a 2x2. And let's look at the write-up for this one. And I'm going back to the SPSS lab sheet, and just looking at the write-up. So a Chi-Square test for independence was conducted to identify a potential relationship between smoker status and gender. This already tells the reader what test is being run and with what variables, and it even gives some of the descriptive information, right? Then, results indicated no significant association, and we have the stats line there. And then I have a little bit of the interpretive statement, with smoking status evenly distributed between male and female participants. So pretty straightforward. We have all of our information in the stats line, and we even provided some descriptives within the write-up as well. Now, assumptions-wise, what we're looking at for a 2x2 is that each of the expected count cells is at least 10, so 10 or greater. Well, we have the 35.8, 148.1, 49.1, and 202.8. All of those expected cells are greater than 10. So no worry with the assumption check for Chi-Square here. Alrighty, let's go on to task 2. On this one, we're asking, is there an association between source of stress and smoking? Like, is there a relationship such that depending on what types of stress people are feeling are major in their lives, what is the likelihood of them having smoking or non-smoking status? And we're going to go to the same place, frequencies, contingency tables, and we can call this one our Chi-Square This one has 9 different types of stress, but still only 2 smoking. So source by smoke. And again, on the rows, I'm going to want to put the source of stress because it's got a lot of levels to it, right? And then on the columns is where I want smoke. Cool. So we have our contingency table started, and like before, I'm going to want to know what the expected counts are. Now, because this one isn't a 2x2, it's a larger table, that means that we can look for 5 or greater in our expected count. So I'm expecting 43.5, 179.4, but then here, 2.3, that's less than 5. See these here that are less than 5? That one seems fine. It expected 5, it only got 1. Here, expected 3.9. So that means we have some assumption violation going on for this chi-square, that there are several cells that have less than 5 expected. So you would want to let your reader know that. But we can still be able to report it. Out of the 223 working stress, 45 of them said they smoke, and 178 of them who reported work as major source of stress said they don't smoke, and then are expected right under that. And then for our chi-square tests, we're fine not using the continuity correction because it's bigger than a 2x2. So we can just use the chi-square normal estimate of 18.38. Our degrees of freedom are 8, and our p-value is 0.019, indicating a significant chi-square test. So that means that there is an association between major source of stress and smoking behavior. So we would want to let the reader know that as well. And we also have our sample size, which is good because with some missing values, we would want to know how many are actually in the chi-square test, 420. So we still need what? We still need our effect size here. So we can go down to, go to statistics and again pick up that phi and Kramer's V. Now, phi is not available because it's not a 2 by 2 contingency table, and we would only want Kramer's V here anyway. So there's our effect size. We can also look at if you wanted percentages listed in here. That way we know 20.2% of people who say work are is their major source of stress indicate that they smoke. And 79.8% of people who indicate work is their major source of stress indicate they do not smoke. And we can put that on our first one as well. The percentages, it helps you explain things to your reader. Go up here. So then we have right there 17.9% of males indicate they smoke, and 82.1% of the males indicate they do not smoke. Cool. I'm going to fold that one back down and just work with our 9 by 2 here. We got our effect size, we got our stats, and we got information that we can use for conveying information to the reader. And this is a lot of information, right? With 9 levels to the categorical variable. So that's why I was suggesting you might want to make a table, either with your descriptives for source of stress, or even if you wanted to make a table somewhat like this. I would say maybe not having expected count on it, like try to find a way to make it cleaner. But this is the information that you can use to build your own descriptives table, either for just source of stress or the contingency table. And the ones that I found that look most similar in the APA manual was table 7.2 or sample table 7.7. Might give you some ideas for how you might work this into a table. So let's see how this might look written up. Again, I'm on the lab sheet for SPSS, but I'm just looking at the write-up parts. So a chi-square test of independence was conducted to identify if there is a relationship between smoker status and source of stress. We have a significant association, and there's the chi-square stats line. Distribution of smoker status was significantly different across various sources of stress, and then it might be easier to use a table to help convey information here, because there's just so many different sources of stress. And then you also want to let your reader know that there was an assumption violation, that we had some areas where expected values were less than 5, and that is a violation of chi-square. Alrighty, one more to go. Let's look at goodness of fit. And chi-square goodness of fit test is a little different. You also hear it called the one sample chi-square, and it's used to compare your sample to a known proportion. So if we already know a proportion, like in the population through CDC statistics, or from a study, a prior study with a larger population, and we already know the proportion of smokers in that, and then we could compare our sample to that prior known, like larger sample or population norm, if you will. And the way we approach this is going to be a little different. We'll go to frequencies again, but now we're going to multinomial test. And I can say, okay, this one is my goodness of fit test for smoking. So now I'm only looking at one variable, right? And it's going to be the smoke variable, And in JASP, a categorical variable is called a factor. So I'm going to put smoke in the factor area. And then I'm going to, so this is not the test we're looking for, because here it's looking for equal proportions, and we're not saying that. We're saying that is the number of smokers in our sample different from the reported in literature from a previous larger nationwide study where they found 20% of their sample was smokers. So we want to let JASP know that we're only expecting 20% to be smokers. So we'll go to Custom Expected Proportions, and here, those who said yes, we want to say this would be at like 20%, whereas the ones who said no would be at 80%. So now I've indicated the proportions that I'm expecting due to the prior population or their prior work. Now this totally changed our chi-square, right? Now we have an estimate of 0.07, still 1 degree of freedom, but our p-value is 0.79, definitely more than 0.05. So we have a non-significant goodness of fit test, which is saying that our sample is not significantly different than the population norm that we know of from a prior large study. So that's the information we would need with that. Other info we might need, we're not going to do a effect size here because it's difficult to get the effect size for goodness of fit test, and realistically we don't have to report effect size for non-significant models, but still even getting the effect size on this one is rather difficult. So what else do we need? We need to know the sample size in this, right? So how many people actually told us their smoke information? We can look at descriptives and be able to see that we had 85 and 351, and we can go back to our descriptives, right? I can just add those, but I can go back to my descriptives and say, okay, in smoke, how many actually reported? We're missing 3, so 436, and you can also see that up in our very first table. Valid 436, missing 3. So 436 is the sample size you need for that last goodness of fit test for that stats line. So you gotta watch that one. It tries to get away. So let's see what that one looks like in the write-up. There we go. A chi-square goodness of fit test indicated no significant difference in the proportion of smokers identified in the current sample, 19.5%, as compared to the value of 20% that was obtained in the previous nationwide study. And then there's our stats line for the chi-square. Interpreting, this result indicates that our sample is representative of smokers in the larger population. So that's good. That's it for what we have done here. Again, look and see what kind of table you want to build from it now that you've built a couple of tables. And we are done here. And we did a lot, right? We've done a lot of chi-square tests, and these are the non-parametric type when we have categorical, both predictor and outcome. Then we're not in parametric test area anymore. We got to go non-parametric. And you'll see chi-square used a lot in research, and it's good to be able to kind of sort through what they're saying. So hope you enjoyed, and I look forward to seeing you at the next lab.